understanding of cosmology has changed radically over the centuries. We'll take a close look at the EU model, but first, to provide some context, let's begin by reviewing how we got here. The earliest paradigm was the intuitive one. The whole universe revolves around the Earth once every 24 hours. But an anomaly was discovered. Some of the stars misbehaved, occasionally reversing direction. This made it impossible to predict their future positions. Claudius Ptolemy was an Alexandrian mathematician and astronomer who found a way to deal with this anomaly. In 160 AD, he suggested the planets moved in small circles while they followed their path around the Earth. He called these small circles epicycles, and they enabled Ptolemy to accurately predict the future position of planets. For 14 centuries, Ptolemy's model was accepted as absolute truth. It made sense, it enabled accurate predictions, and the Church endorsed it because it was compatible with biblical narratives. Then, in 1543, Nicholas Copernicus published The Revolutions of the Celestial Spheres. He put forward the heretical theory that the planets revolved not around the Earth, but around the Sun. He assumed they traveled in circles, and again, this provided inaccurate predictions, less accurate than those of Ptolemy. 6 decades later, around 1610, the German mathematician and astronomer Johannes Kepler resolved the anomaly, as Ptolemy had done in his own day. Kepler's observations revealed the planets followed not circles, but ellipses as they go around the Sun. Around the same time, the Italian astronomer Galileo Galilei and his infamous telescope were able to show conclusively that Venus travels around the Sun. Unfortunately, this got him into serious trouble, as the Roman Catholic Church, led by Pope Paul V, was not ready to give up the Earth's central role in the universe. Nonetheless, scientists continued to pursue the heliocentric model. Around 1680, the German mathematician Gottfried Leibniz discovered calculus. This greatly advanced our ability to compute the paths of objects that travel under the influence of gravity. Armed with his own version of calculus, and allegedly inspired by a falling apple, Isaac Newton came up with his famous laws of motion, published in his famous Principia in 1687. This shifted the focus of cosmology from the solar system to the universe as a whole. Gravitation and the laws of motion governed every part of the cosmos. Even more significant than its emphasis on gravity was the importance the new cosmology granted to mathematics. We were living in a clockwork universe, and one, apparently, conforming to the mathematical laws. This new cosmology was heralded as a profound triumph of science. It brought us insight into the very mind of God and his design for our world. Surely this cosmology would prove to provide a basis for understanding all the remaining secrets of the universe. Thus was born what we now call the Standard Model of Cosmology. All was well for the next 300 years. However, in the modern era, with advanced technology like radio telescopes and space probes, we began to run into problems. In particular, scientists were baffled by the rotation of galaxies. These heavenly objects were refusing to follow the laws of gravity. What do scientists do when their paradigm fails? According to the scientific method, they are obliged to return to the drawing board and reconsider their assumptions. But long-held assumptions die hard. Rather than questioning their cosmological paradigm, scientists retreated into magical thinking. If only a certain quantity of invisible mass, dark matter, existed within a galaxy, then its rotation could be brought into conformance with gravity. Dark matter was born. But there's no other evidence for the existence of such matter. Dutiful physicists are eagerly seeking such evidence, but in vain. At least 4 decades of searching have produced nothing. But even invisible mass was not enough to shore up the gravitational model. In order to account for the way the universe seemed to be expanding, scientists engaged in more magical thinking, dark energy. And again, dutiful physicists seek in vain to find supporting evidence. Once Pandora's box of magical tricks was opened, there was no stopping them. Every time the Standard Model encountered something it couldn't explain, they conjured up yet another impossible solution. Black holes, neutron stars, and the Big Bang are all incompatible with the laws of physics. Mathematical singularities are being confused with reality. The Standard Model, based on gravity, is in crisis. Gravity is not the only all-pervasive force in the universe. There is also the electrical force, which was little understood in Newton's day. And electrical forces are billions of times more powerful than gravitational forces. Fortunately, a robust new paradigm is emerging, one that takes electrical forces into account. This is the EU model, the Electric Universe Model of Cosmology, and its origins trace back to Christian Birkeland over 100 years ago. The first cornerstone of the new electric paradigm was laid down in 1908 by Birkeland as a result of his investigation into the aurora. He conducted surveys of electromagnetic fields in the polar region above Norway in the Arctic Circle. He then followed up with experiments in his plasma chamber and demonstrated conclusively that the aurora are caused by an electric current from the sun. Birkeland's conclusions were ridiculed and dismissed by mainstream scientists until recently, when space probes confirmed the existence of such currents, which are now referred to as Birkeland currents. The fact is that the universe is 99% plasma, a mixture of positive ions and electrons, and plasma is an excellent conductor of electricity. We have all seen currents waving in a plasma ball, and we can see the same kind of currents in the images from astronomers' telescopes. When we see a current in space, what we are actually seeing is plasma discharge as the current interacts with its plasma environment. Sometimes the interaction is not energetic enough to be visible. This is known as dark mode discharge. If the interaction is extremely energetic, as with lightning bolts, that is called arc mode discharge. In between, we have glow mode. These distinctions will play an important role as we go on to interpret cosmic events. One of the most important properties of plasma is that plasma behaves the same on all scales. This means that cosmology can be studied in the lab, as pioneered by Birkeland. Theories about celestial phenomena can often be verified or disproved by setting up appropriate experiments, using sometimes plasma chambers and sometimes electric arcs applied to materials, depending on what is being simulated. The Earth's ionosphere is 250,000 volts more positive than the Earth's surface, not just some of the time, but all of the time. Why don't currents flow from the ionosphere to the surface in order to neutralize this charge separation? The answer is that plasma can form double layers, which function as a natural capacitor. We'll be seeing lots of double layers as our story unfolds. Another plasma phenomenon we need to be aware of is the Z-pinch. Here's a Z-pinch created in the lab by zapping it with high-intensity current. An electric current always forms a magnetic field around itself. Under the right conditions, this field can constrict the current, forming a Z-pinch. Here we see a Z-pinch in a cosmic current, with a star at the center. In fact, a star is created whenever a Z-pinch forms on such a current. The formation of a Z-pinch is how a star is born, and after the birth, the Z-pinch channels the current through the star, powering its functioning. Every star, including our own sun, exists in such a Z-pinch configuration. But in most cases, the process is not energetic enough to be in glow mode, and we see only the star itself with no visible power source. Here we see a current with stars lying along it. The current is powering the stars, like Christmas tree lights along a wire. In this case, the whole current is energetic enough to provide us with glow mode visibility. The Z-pinch funnels the current into the star at both poles, perpendicular to the main current flow. The Z-pinch surrounds the star with two nested double layers, providing charge separation for sure. The double layers prevent the main current from flowing, like a dam holding back a river. Just as the dam may release water to power a turbine, so the Z-pinch funnels the current to power the star. Stars sometimes erupt as novas or supernovas. This happens when the double layers collapse. The main current comes bursting through, like the rush of water when a dam collapses. This burst of current causes intense plasma discharge, which we see as a nova or supernova. Standard model cosmologists have assumed that a nova or supernova event is an explosion that destroys the star. However, a number of recurrent novas have been discovered, which flare up on a repeating basis. 10 such recurrent novas have been identified in our own galaxy. These include notable examples such as Res Ophiuchi and T Coronae Borealis, which have been observed to erupt multiple times over the years. With the standard model of stars as isolated nuclear furnaces, this apparent death and rebirth process is difficult to explain. In the EU model, this flare-up is just a plasma discharge. It is no surprise that the star itself survives. Just as in an electrical power station, where breaking a circuit causes dramatic discharge, while the power station itself remains unaffected. We can understand how a star can survive a flare-up, but why is it happening repeatedly with these stars? Let's take another look at the star's Z-pinch configuration. The star is functioning as a resistor, and the double layers are functioning as a capacitor. This happens to be the same circuit configuration as that of a simple oscillator. While the current is passing through the star, the resistance causes charge to build up on the double layers. When the charge exceeds a certain threshold, the double layers collapse, the current comes surging through, and we get dramatic discharge. The discharge releases the tension on the double layers, the circuit resumes normal operation, and the double layers begin once more to accumulate charge, restarting the cycle. All stars are powered in the same way, and we can expect all stars to have a nova experience on a regular basis. But who knows what the cycle time is for different stars? The fact that only 10 recurrent examples have been found out of billions of stars in our galaxy, this suggests that most cycle times are much longer than just a few years or decades. In the case of our own sun, there is geological evidence that suggests a cycle time of about 100,000 years. The star may survive, but a stellar eruption does have consequences. One consequence is that a voltage spike has set down the current, impacting stars further down the line. For the star's planets, an eruption brings very severe consequences. When the double layers collapse, the whole region around the star experiences cataclysmic electric discharge. The results would be different in different cases, but in general, we could expect planets to be knocked from their orbits, arc discharge to flash between planets, and other dramatic effects. In 1950, Immanuel Velikovsky published Worlds in Collision. He had studied the myths of people around the world and kept finding the same mythic themes. A time of great upheaval, with thunderbolts flashing between planets, Venus appearing as a giant and violent comet, mountain-high tsunamis, and many other catastrophic events. In these myths, humanity's collective memory of our sun's most recent eruption have been passed down to us. The ancients saw the planets as gods, and they described the discharge between the planets as the thunderbolts of the gods. Let us return now to normal times, in between our sun's eruptions. As discussed earlier, Current is fed into the sun through both poles. As the currents approach the sun, they are channeled through the sun's magnetic field, the heliosphere. The heliosphere provides a magnetic shield for the planets, protecting them from radiation and electrical disruption. The current comes into the sun at the poles and travels out over the plane of the planets. As the current passes around the sun, a great deal of discharge occurs. Most of this discharge happens in the corona, and without special equipment, we can only see it during solar eclipses. The photosphere, the bright yellow surface we can see, receives only a limited portion of the current, regulated by a transistor-like circuit configuration. This keeps solar radiation at a constant level, even as the corona is subjected to variable level of discharge. Within the heliosphere, the sun acts as an anode, and the more negatively charged boundary as a cathode. The current accelerates from the sun along the plane of the planets. Each planet is impacted by the current flow. As the current approaches the Earth, it is deflected and channeled by the Earth's magnetic field, the magnetosphere. The magnetosphere provides a shield for the Earth, in addition to the shielding provided by the heliosphere. The Van Allen radiation belts are actually current flows, and it is those flows that generate the radiation. The belts are kept well away from the Earth by the magnetosphere, and so we aren't affected by the radiation. After the current reaches the Earth's ionosphere, creating the aurora, it then passes away from the Earth and continues on its way to the boundary of the heliosphere. The ionosphere provides a last line of defense, insulating the Earth from radiation and electrical disruption. We are protected by the double-layer relationship between the surface and the ionosphere. Between the surface and the ionosphere is something rare in the universe, a zone of non-ionization. Only in such an environment is it possible for a biosphere to develop. This double layer does leak, however. This shows up as atmospheric discharges, thunderstorms, lightning, tornadoes, etc. Above the clouds, there are also seldom noticed discharges, like sprites and elves. It's the electric force all the way down, from our galactic current to the surface of the Earth. Each stage in the process adds another layer of shielding. Now let's look upward and consider galaxies. The strands we see spiraling outward from the center of the galaxy are currents, and along those currents, stars are born and being maintained. These currents are powered from the galactic center. Moving up another level, we have our galaxy cluster. The strands of our galaxy cluster are giant currents or plasma filaments, along which galaxies are born and maintained. This is all powered by a current coming into the galaxy cluster. But how far up does this go? What is the ultimate source of power in the electric universe? I guess that's one of those unanswerable questions, like how was the universe created? Perhaps Nikola Tesla said it best. Quote, "To me, the universe is simply a great machine which never came into being and never will end." Unquote. In any case, it's electrical forces all the way up and all the way down.